calculate the relative molecular masses of different aluminium salts used in the industry. The first one is aluminium oxide hydrate, monohydrate. So the first one is aluminium oxide monohydrate. It contains 2 aluminium atoms plus 4 oxygen atoms, 2 hydrogen atoms. Okay. Now, so we know that the relative atomic mass of aluminium is 27, and so for oxygen is 16, so that'll be 54 grams per mole. 64 grams per mole. So that'll be 110, 118, and 120. So 120 grams of pure aluminium oxide monohydrate would be considered 1 mole of aluminium oxide monohydrate. The second one would be aluminium oxide dihydrate. That contains 2 aluminium atoms, 5 oxygen atoms, 4 hydrogen atoms. So our task is same, so that'll be 54 grams per mole for aluminium, 80 grams per mole for oxygen, and 4 grams per mole for hydrogen. That'll be 134 grams per mole, 138 grams per mole for the relative molecular mass of this aluminium oxide dihydrate. The third one would be trisodium. I think, yeah, it's bauxite. It's trisodium AlF6 hexafluoride. So that'll be 3 atoms of sodium plus 1 atom of aluminium plus 6 atoms of fluorine, a new one. So that'll be 3 times 23 grams per mole plus 27 grams per mole plus 6 times 6 times. So that'll be 115 grams per mole plus 27 plus 69. So that becomes 210 grams per mole, because that'll be 141 and 150 and then 210. So 210 grams of pure trisodium hexafluorine aluminium would be deemed 1 mole of bauxite. So moving on to the next one, that would be the next one I've got is magnesium O4. That is 1 atom of magnesium plus 2 atoms of aluminium plus 4 atoms of oxygen. So that'll be 24 grams per mole plus 54 grams per mole plus 64 grams per mole. There's quite a lot of 4 at the end. So that'll be 27 and 142. So 7 and 130, 142 grams per mole. The fifth one I've got for you is a bit large. It's potassium aluminium disulfate, for obvious reasons. dodecahydrate. So that'll be 1 atom of potassium, 1 atom of aluminium, plus 2 atoms of sulfur, plus 8 and 12, 20 atoms of oxygen, plus 24 atoms of hydrogen. So that'll be, this is how I've broken it down, and the total relative molecular mass comes out to be 447 grams per mole for this complex ore of aluminium. And so we can see it started off from the simplest 120, 134, 210, and then 142, and then 474. So larger the molecule, higher the molecular mass for that pure molecule. So I hope it makes sense. I hope you learned something today, and I hope you benefited from this relative molecular mass exercise.